Hello everyone, welcome back to my channel. I hope you guys are doing well. And before starting the video, I want to request you guys to please like, share, and subscribe my channel for more such videos. Thank you. So today's topic is going to be radicals. But before starting the radicals, I want to remind you people that laws of indices. We are going to use here the laws of indices that we have discussed in the earlier lessons of surds and indices. If you want, you can visit to my channel again and look for the same video, right? So let's just continue. So before starting radical, as I said, we'll be discussing laws of exponents, or you can say indices. So the first law says a to the power m times a to the power n, that is going to give you a to the power m plus n. That's a very basic rule. When your bases are same and you have different powers with a multiplying sign in between, you're going to add those powers. Okay, that's a main and a very important rule. Second, a to the power m divide a to the power n, or it can be written in this form: a to the power m over a to the power n is equals to a to the power m minus n. When again you have the same basis and the different powers with the division sign, then you're going to subtract the powers. Third one, that says a to the power m times n is going to give you a to the power m times n. We are going to multiply the powers when you have a bracket over it. Fourth one, a to the power m times b to the power m. Now you can see that the bases are different but the powers are same. So we'll follow the same thing, but we'll be multiplying the in between part with and making a whole power m, right? Similarly, we can do it in the division form as well. When you have a to the power m over b to the power m, that gives you a over b to the whole power m. Sixth one, that says if you have any negative power of any base, right, then we are definitely going to reciprocate it and making it a positive one. So whenever you see a negative indices with any number, then you're going to reciprocal it and make it positive. Seventh rule says a to the power 0. That means any number, any fraction, any simplifying thing is having a power 0, a whole power 0, that makes it a 1. Okay. Now we are going to add few more things here which can help you better in doing the radicals. Similarly, as I say, if I say a root a times root a, this is a square root. Okay. This thing stands for the square root. When we see a square root, that means the number will be in a pair of 2. When we see a cube root, then the number is going to be in a pair of 3. Similarly, it will go on changing it, right? Which means that if you see a power, I mean third 4, that means there is a pair which makes 4 numbers as one pair. Okay. So if you multiply root a and root a, that is going to give you an a whole term. Okay. So I can write it in other way as well. If you see root a ka square, so that means we can write it as a directly. That's also the same thing, because root a times root a is giving you an a, and if you're writing a whole square of it, that also gives you an a. Okay, let's take few more examples for this. Few examples for this to make it more understandable for you. So if I'm writing a very basic one, that will be like this. Let's just take the first example, root 5 squared. Okay, so that means you can directly write in this form or in this form. I mean, you can expand it and then solve it. Otherwise, if you understand that this is a square root, so you just make a squares one pair, like root 5 times root 5. That is, of course, giving you a 5. This power means that it is occurring two times. The same thing is happening two times, right? That means you are going to make it as a whole number, right? So that's how we write it. Let's take a little bigger one. If I write it 2 root 5 to the whole power 3. Now that's going to be a little complicated one, right? So for that, it is a better option if you're not very handy of it. So please write it. Please open this like this. 2 root 5, 2 root 5 times and 2 root 5. We are repeating this number 3 times because we are seeing a power of 3 here, right? Now you multiply the whole numbers with the whole numbers. So 2 times 2 is 4, 4 times 2 is 8. Alright. Now we can multiply the rest of the numbers. Like root 5 times root 5 is giving you a 5, which we already did here, right? So you just need to understand that if it is a square root, so make two same numbers as one pair and make it a whole. Okay? And then we are left with a root 5 again. Okay? Now you multiply it. 5 times 8 is 40, root 5. I hope this is clear. Let's take one more example. Maybe it can be written in this format as well. 3 root 5 and this. So how will we write it? As I said already, you just multiply the number by number, the whole number with the whole number and the root part with the root part. So I can see that roots are same, right? That will give you a 5. And I can see that negative 2 and 3 are the whole numbers. So negative 2 times 3 will give you a negative 6. Okay? So that means it is a negative 30. I hope this is also clear. See, multiplying and dividing is quite easy for the radical forms. But when it comes to addition or subtraction, I'm just changing the topic now. As I said, we are going to discuss the operations on radicals. So this was about the multiplication thing. This was multiplication in radicals. Now I'm going to switch the topic and writing it as adding and subtracting. Radicals. So for adding and subtracting, one thing is very important which you always need to remember, that when you're adding or subtracting something, it should be a like radical. If you see a like radical, then you're going to add it or subtract it. Okay? Otherwise, you're going to leave the radicals as it is. Like radical means, I'll give you an example now. If I'm talking about 3 root 2 plus 4 root 2. Okay. So here you can see that root 2, as I'm saying, that you can see that root 2 and root 2 are same, right? That means we are going to consider this as a like term. Okay, like radical. Now you can easily add it. 3 and 4 is 7 and root 2 remains root 2. Here some students will write 7 root 4. That's a wrong thing, beta. You need to understand one thing, that root 2 and root 2, we are not multiplying here. We are not adding the inside roots. Okay, as you cannot do that. So it is really, you need to understand that when you see the like terms, you just write it as it is. Only the forward numbers or the whole numbers are going to be added or subtracted according to the integer formation. Okay, like let's take few more example. If I see 3 root 3, negative root 3 and plus 2 root 3. So if this is a question, so I can see that all of them have root 3 as common thing, right? You can do it like this as well. You write root 3 as common and the inside numbers are 3. Here, if it is nothing, you can write 1 here. So it is -1 plus 2, like this. So it can be easily coming out to be root 3, and 3 plus 2 is 5, 5 minus 1 is 4. So the answer is coming out to be 4 root 3. That's your final solution for this. See, I am not changing root 3, and you are also not supposed to change root 3. Okay, this is one way of solving it, or you can solve it directly with this method as well. If I am writing 3 and 2 addition thing, which is giving me 5 root 3 minus 1 root 3. So that is also giving me 4 root 3. So this could also be one of the method of solving it. Okay. In addition and subtraction, you need to understand this thing. Let's take a little more complicated one. 6 root 6 minus 2 root 2 minus root 2 minus 5 root 6 plus 4. Okay, so firstly you just shift the you just arrange the like radicals first. So I can see root 6 here and here, so I can write 6 root 6 and minus 5 root 6. Now take the next one. This is root 2 and root 2, so I'm writing negative root 2 and negative 1 root 2. Okay, and the leftover number is 4, which could be written as it is, right? I cannot change it. It has no radical in it, so we are going to write it as it is. Okay, now you can see that 6 minus 5 is going to be 1 along with root 6, because we are not changing root 6 here. Root 6 is the like one. Now here it is negative 2 and negative 1, so it is negative 3 root 2 and then plus 4 as it is. See, here we didn't solve the plus 4 thing, so we are writing it as it is. Okay, as I said, you only need to check the like radicals, otherwise no need to solve it. You can leave it as it is. I hope this is also clear. Now let's take few more operations. I mean, not the operations, as I ended here 8th, and now I'm taking up the ninth property. Ninth property is basically for the division, and 10th is all, 9th and 10th are basically for the division and multiplication of unlike radicals now. So here we are saying unlike radicals. Unlike when the two roots are different, okay, like root 3 and root 5 in one equation or in one expression. So those are different. Like root a times root b is going to give you, or you can combine together to make it root a times b inside the whole root. Okay, and similarly you can do it for the division one. If it is written like this, you can take a whole root and a over b in the same root. Let's take few examples of it. If I write 2 root 5 times 3 root 2. See, earlier we did the questions which are looking same, but here the like radicals are not there. These are unlike ones. I can see root 5 and root 2 here, right? So these are different. Okay, so 2 times 3 is going to give you a 6, and root 5 root 2 is giving you a root 10. Now one more thing is important here. You have to check that whether the inside root part is giving you the prime numbers or not making any pair. Okay, see, I am going to factorize it. So it is giving me 2 and 5 as a factor which is unpaired. So we cannot take anything out from it. Okay, I'll be taking an example in which we have to take it out, so to make sure that we are understanding it, right? So let's just take this more example, root 32 over root 2. Now this is in division form. I can make it in a common root, root 32 over 2 directly. I can cancel it it is going to give me a root 16 over 1. So over 1 is not required to be written. You can leave it. So root 16. See, root 16 is actually a perfect square, right? So you directly write a 4 here. Otherwise, if you don't understand this concept, you can simply make the pairs of it. Okay, I'll take the prime factorization of it. 2 times 8 is giving you a 16 and 2 times 3 is giving you an 8. 2 fours are sorry. It is 2 times 4 giving you an 8 and 2 times 2 is giving you a 4 and 2 times 1 is giving you a 2. So I can see this is one pair and this is second pair. Okay, if you want this term to be expanded, so you can write it like this: 2 times 2 times 2 times and 2, right? As I said, in the square root we make two numbers as one pair and take it out. So that means 2 times 2 is one pair and 2 times 2 is another pair. So for one pair you'll take 2 out from here and 1 from here, which is going to give you a 4, which is actually written here. So both are same. Both ways will work. See, the splitting thing, the expanding thing, the simplifying thing, all of them are all together the same thing. You just need to understand what we are exactly doing. You need to understand the concept of the square root. You need to understand what is a like term and what is an unlike term, or an unlike radical like radical. Let's take one more question. But before that, I am going to request you guys to please like, share, and subscribe my channel for more such videos and for more such concept. And I want you to press the bell icon as well, so that whenever any new video is coming up, you guys will be the first one to see it. Thank you. So next example is negative 3 root 2 times root 2 whole cube. Now, this is a very interesting one, right? So, it is very important to split the question first if you are not able to understand it, right? See, I am a very, a general person. I don't understand it really. So, what I'm going to do is I'm taking the baby steps here, okay? So, I wrote the same thing because this is already in the expanded form, which is negative 3 root 2, and then I can write root 2 times root 2 times root 2, as it is occurring three times in this expression, right? So I can see that I have written everything. Now this root 2 and this root 2 will give you 1 as a pair, and similarly this and this will give you one more as a pair, right? That means negative 3 times 2 times 2. Okay, now you multiply it. That will give you the final solutions. That is negative 12. Look how easy is this. You just need to understand the concept. If you're not really able to grab it orally, just make the baby steps out of it, write it in separate forms, and then merge it. This will be the easiest and the bestest option you guys can do. Let's take another example. I just want you to write all these things in a different way or in the simplification way, right? This is a very common question amongst different curriculums and different schools. So I just want you to take this as a main question. If I'm writing root 200 and I want you to write it in k root 2 form, okay, so what will be the value of k? That's an interesting one. Sometimes you guys can see these style of questions in your MCQ test, in your Olympiads, some sort of these style of questions, right? So it's better to make the baby steps again, right? As I said already, just take the baby steps if you don't understand how to split this 200, right? So I am going to take the factors of 200. So firstly, it is easier for me to take a 5, right? So it is giving me a 40, because in 5 table 20 is coming on 4 and 0 is as it is. Again, I can take 5, which is giving me 5 8s are 40, or 5 times 8 is 40. Then 8 is easily splitted like this, which you guys can already understand, like this. Okay, now how many pairs you can see? This is one pair of 5 and 5, and this is another pair of 2 and 2, and 1 2 is remaining here, right? So it is your responsibility or your liking if you want to write it like this: 5 times 5, 2 times 2, and one more 2, and make a pair here and take 5 times 2 and root 2 inside, because that is an unpaired one. This one is unpaired. So we are putting it in the under root only. Okay. We're not going to take it out because it is unpaired. Now we have k root 2 here and k root 2 here. You can see root 2 is common here, right? You can cancel it. And k is directly coming out to be a 10, which is 5 times 2, right? This is how we can do it. This is really simple to understand. You just take few more questions like this, or if you guys want, I can share the worksheets to you, or we can plan some quizzes over it. Now let's take a different thing here, but before jumping on to the next thing, I am again asking you guys to please like, share, and subscribe my channel for more such videos, for more such concepts. I am thinking to make it little more in a creative way, or maybe in an attractive way, so that you guys can easily understand. So that's all for today. I hope you guys like it. I hope to see you guys soon. Take care.